Okay, loci proper, section 16.2, page 142143. Okay, let's just write a few words here. We've got the word loci, that's the plural. And locus, that's singular. Now, two ways of looking at what a locus is. So if we go down here, what is a locus? It is the path that a moving point follows. Let me just define that. A path, it's actually the path is better. So let's just destroy that. It is the path that a point follows. It will make better sense once we start doing some proper questions. Another way of looking at it, a set of points, in other words loci, a set of points which move according to a given rule. Now again, I'm going to put some flesh on this in a minute. That's just the bare bones of it. Yeah, that's it. A path the path that is taken by a certain point, the path that a point follows, or a set of points which move according to a given rule. Now let's look at Jill. This is question 2, very low level. We're trying to describe loci. Right, Jill goes up a park to play. Well done her. She goes on 2 slides to swing around about. She's going to use all that. Now sketch the side view of the locus of her head as she goes down the slides. That one and that one. Well, if you imagine her head being like the little point, and the rule is slide down here, what will her head do? She stays straight and just slides down. Her head would do something like this, wouldn't it? So it would just go like that. Okay, that is the locus of the points. In other words, lots of little snapshots of her head as she goes down the slide. So going click, 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 taking all those little pictures. It's as though we're going to join each little picture of her head with a straight line, and overall we get a straight line. This is the path taken by her one point, her head, or the points represented by her head as she moves according to the rule. The rule is slide down and we'll take a snapshot of all the little pictures of your head and join them up. So 2 ways of looking at it. One point that moves, doing, or those little points that go doing, 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 doing. The net effect is the same. So that is the locus of Jill's head. Now here we have a curvier path, so therefore her head would probably go up here and round again. Okay, that's the path we're going to get. Now what about this part B? Sketch the side view of the locus of her head. Good wording. As she plays on the swing. What's that going to do? It goes back and forth. It's going to follow a path that looks a bit like that, and back and forth and back. Essentially, that's your answer. It's that curved line there that demonstrates the path that her head takes as she swings back and forth on the swing. Now, sketch the plan view, part C. Sketch the plan view of the locus of her head again as she rides on the roundabout when viewed from above. So Jill's playing on there, and she's probably sort of standing there and holding on to this little bit. Now if we look up top and she goes round and round and round, we should see a perfect little circle, and Jill's head is somewhere on this path. A second or so later she's here, then she's here, then she's here, then she's here, and she keeps going round and round and round. So if you like, her head is the point, and that point follows a given path. Or if we look at snapshots of this one point, then it's the set of points which move according to this given rule. Now just check how the book defines it. Yeah, it is a path that a moving point follows, or a set of points that follow a given rule. So, got the idea? Things that move, join them up and show a path. That's a locus. Now, next bit. Quite difficult to answer this freehand, and certainly the answer I'm about to give you may not match the answers you're going to find in your answer sheets. Essentially, most cars have one of the 3 arrangements. This is question 6 of windscreen wipers shown below. Now for each arrangement, sketch the area of windscreen that the wipers will clear. So let's have a look at this one first. Obviously we can pretend this is a kind of radius thing, and it will sort of move in a circular fashion, won't it? So let me sort of imagine that sort of thing happening. It won't go all the way back, I don't think, so it might sort of stop there, I suppose. And this one likewise sort of would do something like this, and you might stop about there, I suppose, I don't know. So essentially this is the kind of area that's going to be covered with these two windscreen wipers. So let me sort of shade that out a little bit. Okay, so I sort of make that the answer, really. Again, not very accurate. The idea is that you understand that we're looking for a moving point. If you imagine the point there as being the point that we're focusing on, the locus of the path of that point is that, and the locus of the path of this point is that. That's what we've got. Let's go to this one. I suppose this will start about here somewhere and go round and sweep and then go back and forth, and that's the locus of the point, moving according to that rule there, and this will be the area it would cover. I can't tell which is better, that one I really just don't know. Let's just try this next one. Here these go backwards and forwards like that, so it might start, say, here and go round. Well, this should have been black, shouldn't it? Like that. So we'll stop it there, and this one would go round like so, so far maybe, and then sort of stop there, won't it? Alright, so this is the path, the two paths of the loci of each individual windscreen wiper, so that little point would go back and forth, back and forth, back and forth. Now, question, for each arrangement sketch, I've done that, which is the best arrangement, and give a reason. I honestly can't tell. I suppose you've got to judge the biggest area covered by both windscreens. Now, if we're looking at England now, the UK, the driver sits on the right, so here he is, there, or here she is, and there he or she is, and here, there, he or she is there again. Now, according to my very crude diagrams, B would be a terrible arrangement because it doesn't reach very far into the driver's field of vision. So the driver's sort of sitting here looking out towards us as you're looking at this video right now, and his windscreen doesn't really touch where he is. Not very good. C's pretty good. His side gets cleaned up good, as so does the passenger's side, and so does A. But I can't really tell which is the best. Honestly, I can't. Certainly I wouldn't recommend B because it doesn't sweep enough area of the windscreen. Now, if I check in the answer book, it says that the first arrangement is probably the best as it has the smallest area on the left. In other words, as it has the smallest area on the left, that, on the driver's side, that is not covered. In other words, most of the area on the left is covered, and I couldn't really distinguish between that one and that one, honestly. Don't worry about it. And certainly the answers in your answer sheets are wildly different from mine, and as far as their windscreen wipers are bigger anyway, and they seem to cover a bigger area. So anyway, not a problem. Thing is, we're doing loci, we're not designing windscreen wipers. So this is what you need to look at: the path that the point at the end of the windscreen wiper will follow. That, okay, done. Turnover. Right, now we're getting into it proper. This is question 9. No, it's not question 9, it's question 10. It says, describe the locus of all the points 5 centimeters from a fixed point P. Okay, well, here's a fixed point P there. Right, I've got to put loads of points 5 centimeters away from P. Well, suppose that's 5 centimeters, and that, and that, and that. What if all these are exactly 5 centimeters away from P? Again, it's a freehand sketch. Now, if I'm going to stay 5 centimeters away from P, these are my points moving according to a rule, or one point following a path. What have I got? I've got a circle of radius 5 centimeter. Describe the locus? Yes, the locus is a circle of radius 5 centimeters. Got that? That's how I describe it. Now we get into the grade C's now. B. Describe the locus of all the points which are 2 centimeters from the circumference of a circle of radius 6 centimeters. What a mouthful. First, let me draw a circle, and I'm going to pretend that has a radius of 6 centimeters. So that is 6 centimeters, okay? I've got to describe all the points which are 2 centimeters. Sorry, the locus of all the points which are 2 centimeters from the circumference of a circle that has a radius of 6. Right, I'm going to be 2 centimeters away from this. So supposing if that's 6, that will be about 2. So here's my locus. I am trying to be, this is really hard to draw on this thing, I'm trying to be 2 centimeters away from that circumference. I really am. Now, there it is. What I've produced, therefore, is a circular path of radius 8 centimeters, because the 6 plus the 2 centimeters makes 8 centimeters. So that's my locus of the points which are 2 centimeters from the circumference of the circle, and that is therefore a circle of radius 8 centimeters. But wait a minute, if I'm 2 centimeters away from my circle, why can't I be 2 centimeters away from my circle on the inside? I can. Therefore, I've got two answers here. If I'm 2 centimeters away outside the circle, I can be 2 centimeters away inside the circle. So I've got another rule happening, another locus happening, and it's like this. There it is. So essentially what I have is not a 6 centimeter radius, but a 4 centimeter radius, because from here to here is 2 centimeters away, isn't it? So there I go, 4 plus 2 is 6, and I've got a little baby blue circle inside. So here's my second answer. It's a circle of radius 4 centimeters. So these are the loci, alright? Single locus, 2 loci. 2 answers within one scenario. Alright, that's really good. Now, next one. Here I go, more traditional abstract loci. I've got to describe the loci shown with the red lines in each diagram. So let me describe what I see. So this is A first of all. What is that? It is a circular path around a fixed point. I can't quote a radius because I don't know what it is. But it's a circular path. Getting glitchy now. I really don't need this now. A circular path around a fixed point. Is that alright? So I'm saying that wherever this point is, whereas I move around this fixed point, call it P, it'll always be the same distance from it all the time. So it's a circular path around a fixed point. B. Look at this. This is a path around a line in a fixed position. So it is a path of a point equidistant from the line shown. And let's just think about that. It is a path of, say, this point that moves, and it's always the same distance away from the line. Obviously the straight parts are easy to understand. Look, I'm the same distance away from the black line, the same distance away from the black line. Now as I hit this part here, I've got to form a circular path, a circular arc around, then come round again. Whatever happens, I am the same distance away from this fixed line here. So it's the path, this locus here, this red locus, is the path of a point which is equidistant from the line shown. C is quite hard to explain. I don't like the answer given in the answer sheets at all. Essentially, it is the path which follows, which is always closer to one line than the other. Okay, it's not equidistant. So, for example, here my point is here at the moment. I'm a lot closer to the black line than I am when the point reaches this point, this position, right? So we can't use the word equidistant, but it's this red line, this path is always nearer this line than that line. Okay, so the path of a point which is always nearer one line shown than the other. And part D is quite straightforward. Okay, these are the black lines, and this red line here, I don't know how red it looks to you on the screen, but it's reddish here. This red line is the path of a point which is equidistant from both lines. Getting glitchy. From both lines shown. Oh, it's getting very, very difficult. From both lines shown. Let me try and write it. You've heard me say it 3 times now. Both lines shown. Done. Okay. Essentially, I'm going to walk between these 2 black lines, and the way to do it is to start here and go off in that direction. I can, of course, start here and go in this direction. Essentially, the way you construct that is to bisect the angle. If you bisect the angle, you know your construction line, your locus in this case, will be exactly half of the angle that I've just shown right now. Right? So that is equidistant between this line and this line, and it behaves as a bisector of that angle. Really hard. I'm going to need to stop and review what's happening. So I think that's done in terms of introducing loci and describing loci. I'm now going to give this computer a little rest.